Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Carbocation stability increases with I. Resonance conjugation, 2. Electron donating groups, EDG, such as alkoxy, OMe, directly stabilizing via lone pair donation, 3. Hyperconjugation and inductive effects, and 4. Substitution, tertiary secondary primary. Moving on to the next step. Option A. The positive charge is on a carbon that is part of an allylic system, CH2 is equal to C, CH3, and the OMe group is on the other end of the conjugated diene system, C, OMe, is equal to CH. The carbocation is allylic and vinylogously stabilized by OMe, but the positive charge is on a less substituted terminal carbon. Option B. The positive charge is on a primary carbon, CH2+, adjacent to no alkene or OMe directly. The OMe and alkene are present but not directly conjugated with the cationic center. This is the least stable. Option C. The positive charge is on a tertiary carbon that is also allylic, C+, CH3, adjacent to CH is equal to CH2. However, the OMe group is on a saturated sp3 carbon, CH, OMe, 2 carbons away and cannot donate electrons by resonance to the carbocation. Stabilization comes from tertiary character and allylic resonance only. Option D. The positive charge is on a carbon that is simultaneously 1. Allylic with respect to the isopropylidene group, CH is equal to C, CH3, 2 and 2 directly conjugated with the C, OMe, is equal to CH vinyl ether system. This means the OMe oxygen can donate its lone pair through the extended conjugated system directly to the carbocation center. The structure is CH3C, OMe, is equal to CHC+, CH3, CH is equal to C, CH3, 2. The cationic carbon is tertiary, allylic on both sides, and in conjugation with the electron-rich OMe-bearing alkene, making it a highly stabilized oxocarbenium-type extended allylic cation. Moving on to the next step. In option D, the carbocation benefits from tertiary substitution, allylic resonance toward the isobutyl side, and direct conjugation with the methoxy-substituted alkene, vinyl ether resonance, allowing OMe-oxygen lone pair donation all the way to the positive charge. This cumulative stabilization is the greatest among all options. And for the final step. A. Lacks tertiary character at the cation and OMe conjugation is less direct. B. Is primary and poorly stabilized. C. Has tertiary allylic stabilization but OMe is on sp3 carbon and cannot conjugate. Therefore, the correct answer is D. Therefore, the correct answer is option D.